So this is sequences series day number 2, convergent divergent sequences. All right, so BC problems are embedded in all of the homework. Go ahead and try them, please. They'll be good practice. Don't start practicing for the BC and IB exam in April. That'd be a bad idea. So I got keys to that, I think, on the homework. So a sequence, like I said, is just a list of numbers and those values given. So this sequence, in this case, n over n plus 1, as you can see, first term, second, third, fourth, fifth, what is that converging to? 1. So the sequence converges, right? What's another way I could visualize this? Well, I could visualize this as a function, which we'll get to in another slide here in a moment, but I'd like you to see this. Let's say that this sequence, f of n, is n over n plus 1. Could I maybe just visualize that like a function? And so what would be the limit as n goes to infinity of said function or sequence? Right? Degree on the top is 1, degree on the bottom is 1. Therefore, as we go to infinity, I take the two coefficients and I divide them, right? There you go. Sequence converges. Okay. Now, let's take another example. Let's say my function or my sequence is n squared over 8n cubed minus 72. Well, just think of it as a function. X squared over 8x cubed minus 72. What would you have done? Take the limit as x goes to infinity of said thing. Now, why would I do this? Right, why would I do that? Because it doesn't matter, right? Whatever is hanging off the end, I just take the two highest powers and compare them. Well, I could use either L'Hopital's rule, right? Or I could do said thing, right? Divide both terms, top and bottom, divided by, oops, that should be an x cubed. So if I did that, what would the numerator turn into? X squared over x cubed would be 1 over x, right? And 8x cubed over x cubed would be 8. And so the limit as x goes to infinity would be 0 over 8, which would be 0. So the numerator's power is lower than the denominator, therefore it will go to 0. What would happen if the numerator's power was 3? I'd get 1/8, right? Because then this would be 1, and I get 1/8. What if the numerator's power was an 8? Well, then I'd have a problem, right? The numerator will grow quicker than the denominator, it'll take off to infinity, and there would be no limit. So that would be a divergent sequence. Okay, so we're going back to the different methods that we've seen. Here's just a couple properties. If you have a constant inside, right? If I have a constant multiplied by the sequence, I can just pull that out and then take the limit of the sequence and multiply it by the constant at the very end. That works. Here's an example. I'm not going to touch on it. You can look at it in a little bit. It's just touching on, can I take a sequence and compare it to a function, right? A function is continuous, a sequence is not. This is just P series, right? We've seen this before. That sequence will converge to 0. That's great. This one will converge to 0, however, its series will not. We're going to touch on that. That's called the harmonic series. We'll see that later. This is just the comparison test, so all that this is going to say is if B is greater than A and A diverges, then B does as well. If B is greater than A and B converges, it forces A to converge. We just did that on our last test. Okay, just a little bit of algebra of limits. Here's an example you can touch on in your own time, and I want to look at a couple of our own. Do you remember the squeeze theorem at all? If I could say that a function is between two things, let's say 0 and another function, and the upper function converges to 0, it forces or squeezes that middle function also to converge to 0. So we're going to see the squeeze theorem in this example here in a moment. What would you say right now to this? You got any guesses or hypotheses on whether or not this will converge and what it'll converge to? I see a power of 2 on the top, power of 2 on the bottom. I would say 2 is probably a pretty good guess, but it's dependent on this. Like, what the heck is that thing going to converge to? I got a problem with that, right? So let me do this real quick. I'm going to take this A of n, right, our sequence, and I'm going to multiply the top and the bottom times 1 over n squared. So I'll get 2n squared plus 4n minus 3 and n squared minus 4 natural log of n. And I'm going to divide everything by n squared. One of our methods from a long time ago. Honestly, you guys, after I think about how I taught things, I don't feel like I taught them great, but I get one shot at it every day. Felt like Eminem every day. You only get one shot, right? You only get one shot. All right, so let's simplify this. 2n squared over n squared would simplify to 2. Okay, I like that. That's what we thought originally. 4n over n squared would be 4 over n. 3 over n squared would just be what it is. In the denominator, n over n squared would be 1, and then I have questions here, right? I have a question about what's going to happen there. So now I'm going to employ my squeeze theorem thoughts. Ready for this? Squeeze theorem thoughts with Lud. Yeah. I know, you're like, yay. All right, so I'm going to take this thing 4 natural log of n, and I just want to compare it to something. Is that going to be greater than 0 if n is greater than 0? Well, if n is greater than 1, right? Because natural log of 1 is 0. If n is greater than 1, yes, it'll be greater than 0, right? So I can at least say that. I can say that much. Well, here's a nice thing. Wouldn't that always be less than 4n? Yeah. Right? That would always be less than 4n. Now, this isn't quite what I have. I have over n squared. Right? So I'm just going to put everything over n squared. And then I'm going to take the limit of those as n goes to infinity. Now, let's clean this up a little bit. 0 over n squared is still going to be 0. I'm going to take the limit as n goes to infinity of all of these. Well, what's the limit as n goes to infinity of 0? 0. It'll stay 0. Limit as n goes to infinity of 4 natural log of n over n squared. I don't know what that is. Do you? I don't either. I don't really care, but I do know this. Limit as n goes to infinity of, let's reduce this. 4 over n, p series. Stick, what will that go to? 0. 0, right? P series. What is the exponent of n? 1. We said that 1 over n to the p, the limit as n goes to infinity, of that will converge to 0 if p is greater than or equal to 1. And therefore it is. Squeeze theorem. So now if this thing, limit as n goes to infinity of 4 natural log of n over n squared, let me erase this. I know this goes to 0. If it's between 0 and 0, what must it be? 0. Okay, so it must be 0. So look at that. We could throw 0 in there. And as we take the limit, as n goes to infinity of said thing, this will go to 0, this will go to 0, and we get 2 over 1. So good guess for those of you who thought 2. Now that 4 natural log of n over n squared won't always converge. Won't always, but in this case it did. All right, so let's employ squeeze theorem to show that the limit of this sequence, or the convergence of this sequence, exists and it converges to 0. What do you think we should do? Start. So sine of n, yeah, we can't say it converges because it oscillates, but we do know that it's less than 1 and it's less than or equal to 1 and greater than or equal to negative 1. Okay. Well, that's not what I have. I have sine of n over n. Okay, well, here you go, child. Just divide everything by n. Oh, hello, P-series. Hello, P-series. Oh, hi. So, oh, that's end of the first, and that's end of the first. So if I took the limit as n goes to infinity of -1 over n, does that converge? By P-series to what? 0, correct. So that equals 0. What do I know about the same thing on the right side? 0 by P-series. Therefore, if this is equal to 0, and 0 will be less than or equal to sine of n over n, which will be less than or equal to 0 as well. Oh, cool. Sine of n over n must converge by the squeeze theorem. Yes, sir? Sine of theta over theta as x approaches 0 is 1. Yeah, as x approaches 0 is 1. But as it approaches infinity, right, it goes to 0. Yes, Blake. And say, therefore, by squeeze theorem, I'll spell it all out, to be the limit as n goes to infinity of sine of n over n would equal 0. Therefore, you could say it converges. Yep. Yeah, you're going to want to be formal about it. Sometimes I think just due to the nature of me, I tend to relax on that, but you should never relax on writing out a formal therefore statement at the end. Okay. All right. Let's see if there's anything out there that's ugly that you just feel like you want to see. B? D? Okay. B? And A? Oh, I can write this. I can write this as the limit as n goes to infinity of 1 over n plus the limit as n goes to infinity. That's not an 8. That's an infinity of 1 over n cubed. And guess what I can say about both of those? They both converge by P-series. Therefore, the sum of them would converge by P-series. Right? Okay. How about B? Well, what can I say about this? What can I do with these two things? Divide them because it's subtraction, so it'd be 1 plus n over n. And I could actually rewrite that to be 1 over n plus 1. And do you remember this? What is, as n goes to infinity, oh, I'm sorry, I got that goofed up with another problem. What would the natural log of, what would 1 over n go to? As n goes to infinity, that'd go to 0. So the natural log of 1 is what we get, which is, natural log of 1 is 0. Yeah, so this would approach 0. Cool. Yes, sir? This right here, if we were to take the series, the sum of those, that would diverge. But this would converge, right? And a divergent value plus a convergent value would still be a divergent value. Oh. Right. So no, it's 1 over infinity, right? As n goes to infinity, this would be 0, and that would be 0. Therefore, this would be 0, right? The limit as n goes to infinity of that. Now, if we're talking, let's not get into series. Oh, don't use your calculator. What is n factorial? It'd be n times n minus 1 times n minus 2. I'll just go n minus 2 factorial. Right, what would n plus 3 be? N plus 3 times n plus 2 times n plus 1 times n factorial. Oh, and look at that. N factorial just cancels all of that. So I get 1 over n plus 3, n plus 2, n plus 1. And what will that go to as n goes to infinity? 0, right? That'll be 1 over infinity, which will be 1 over infinity, which will be 0. This one will use a conjugate multiply by conjugate here. I would say divide by 1 over root n here, or multiply by 1 over root n. That'll help you there. And then if you're a skateboarder, just be careful.